Hello everyone, welcome to Medjo and this is Karthik. Okay, last video we saw about vitamin A guys. So in this video we'll continue vitamin D. So it is also a important 15 mark question or else a 10 mark question, and you can refer these notes for to attend those questions. Okay. First, as usual, we'll see the formation of vitamin D. Okay, it is common name is cholecalciferol. You have to remember this name, cholecalciferol formation. It is derived from 7-dehydrocholesterol or from ergosterol by the action of UV rays. Okay, we'll see the actual formation in next. Okay, 7-dehydrocholesterol. It is an intermediate of minor pathway of cholesterol synthesis, and you will study this in cholesterol synthesis. Yes, it is an intermediate of cholesterol synthesis. Vitamin D2 and vitamin D3. Ergocalciferol and cholecalciferol. Ergocalciferol is found in plants and cholecalciferol is from fish liver oils, milks, eggs, etc. Okay, actual formation. How cholecalciferol is being formed? Vitamin D is formed. Okay, in skin, no. UV light breaks the bond between the position 9 and 10 of steroid ring. Okay, ring B is open because of the ring B is open, so which forms the provitamin secosterol. The cis double bond between the fifth and sixth carbon atoms isomerize to trans double bond where in secosterol, and it forms vitamin D3 or cholecalciferol, and hence active vitamin is formed. So vitamin D is called sunshine vitamin. So because of this reason only, because of this process only, vitamin D is known as sunshine vitamin. Then production of vitamin D in the sun is directly proportional to the exposure to sunlight and inversely proportional to the pigmentation of the skin, and it is a very important point, and it is also a self-explanatory point. Okay, I will read it again. Production of vitamin D in the sun is directly proportional to the exposure to sunlight, okay, and inversely proportional to the pigmentation of the skin. Okay, vitamin D deficiency is seen in winter season. Okay, now it's winter, right? Exposure to sunlight does not result in vitamin D toxicity since excess provitamin D3, which means cholecalciferol, are destroyed by sunlight itself. Okay, so even though it's a sunshine vitamin, you're going to be telling we have to be exposed to sunlight, then only we'll be getting vitamin D. Okay, here what they are telling, overexposure to sunlight does not result in vitamin D toxicity. Okay, we have seen vitamin A toxicity, hypervitaminosis in vitamin D, right? So exposure to sunlight doesn't lead to vitamin D toxicity because excess provitamin D3 are destroyed by sunlight itself. Okay, okay, this completes our first page. Then okay, and 2 points are there. 7-dehydrocholesterol and ergosterol are called provitamins of vitamin D. Okay, these are all provitamins. I have written in red color. Okay, see, I have used various colors which I have written in red color. No, those points are very important and you should not leave those points. Vitamin D is derived from fungus ergot also. Okay, then activation. Okay, activation of vitamin D. Vitamin D is a pro hormone. Okay, steps. How it takes place? First, cholecalciferol is first transported to liver, okay, where hydroxylation at 25th position occurs to form 25 hydroxy cholecalciferol. So cholecalciferol is transported to liver. In the liver, 25th position, hydroxylation occurs and it is converted to 25 HCC. Okay, I'll be short form. I'll be telling as a short form 25 HCC. So 25 HCC is the major storage form of vitamin D. So in plasma, 25 HCC is bound to vitamin D binding protein. So in vitamin A, we saw about retinol binding protein, right? So same way in plasma, 25 HCC is bound to vitamin D binding protein VDBP, which is known as alpha 2 globulin. So that vitamin D binding protein is known as alpha 2 globulin. So 25 HCC is bound to alpha 2 globulin in plasma. So in kidney, okay, from liver it is transported to kidney. In kidney it is further hydroxylated at first position, which forms 125 dihydroxycholecalciferol, nothing but DHCC. Okay, Hydroxylation occurs at liver first time, and second hydroxylation occurs at kidney, and it is transported to plasma with alpha to globulin. Simple. Since it contains three hydroxyl groups, okay, at 1, 3, and 25, 1, 3, 25 positions, it is also called calcitriol, which is the active form of vitamin. So calcitriol, you have to remember vitamin D. When you say vitamin D, the first word you have to remember is calcitriol. Okay, I have given the process in a chain like 9, cholecalciferol, 25 hydroxylase in liver, 25 hydroxycholecalciferol, 1 hydroxylase that is transported to kidney, and kidney 125 dihydroxycholecalciferol, it is nothing but calcitriol. Okay, so calcitriol plays an important role in bone formation and calcium metabolism. I have given in caps, okay, because it is an important and basic point in vitamin D. Okay, calcitriol plays an important role in bone formation and calcium metabolism. Okay, we complete the second page. Okay, note what note here. Okay, what is being written? Okay, calcitriol and calcitonin sounds similar, right? Okay, we'll see the difference. What is calcitriol? Now we have studied, right, active form of vitamin D which increases blood calcium level. Okay, so vitamin D, calcitriol, it increases the blood calcium level. Okay, calcitonin, it is a peptide hormone released from thyroid gland which decreases blood calcium level. So vitamin D plays an important role in blood calcium, maintaining the blood calcium levels. You have to remember this. We will be studying in physiology also in endocrine chapter. We'll be studying briefly about this process, how calcitriol and calcitonin both plays a major role, and how parathyroid hormone affects the calcium maintaining process in plasma also. Okay, so these note, okay, don't remember this calcitriol, triol. When you pronounce, it's like pronounced like something great. Calcitriol and calcitonin. See, calcitonin decreases. So by this you can remember this. So calcitriol increases the blood calcium level and calcitonin decreases the blood calcium level. Okay, as absorption, transportation, and storage. Okay, like in vitamin A we saw, right? Like in vitamin A, retinol is converted to retinol and is transported to liver and blah 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 blah. So it is the same way how vitamin D is absorbed, transported, and is where it is stored. Okay, vitamin D is absorbed in small intestine along with fats and with the help of bile salts. See guys, see, all the fat soluble vitamins are being absorbed with fats and bile salts only. So, and also it is absorbed in intestine. Okay, so intestine is a major site of absorption of vitamins. So in the intestine, vitamin D is incorporated into the chylomicron, same way how vitamin A is transported in the circulation. Vitamin D binds to the vitamin D binding protein, the retinol binding protein, here vitamin D binding protein, and transported to different tissues. So vitamin D is stored in liver. So in vitamin A is stored in liver as retinol palmitate, we saw, right? The same way vitamin D is stored in liver. Okay, what are the biochemical effects of vitamin D? Sites of actions are where vitamin D, major actions of vitamin D is intestinal villi cells, bone osteoblast, kidney distal tubular cells. Okay, how it acts in intestine? We saw, right, calcitriol plays an important role in calcium absorption and transportation and maintaining blood calcium level. Here we saw a basic of this. Intestine, calcitriol, it increases the intestinal absorption of calcium and phosphate and increases the blood calcium and phosphate level. So how calcitriol increases the blood calcium level? By increasing the absorption of calcium from the intestine, and thus increases the blood calcium level. Okay, so the same way action of calcitriol is similar to steroid hormones. Okay, how it happens? It binds to a receptor in the cytosol, and this complex is then transported to the nucleus, where it acts on DNA to stimulate the synthesis of calcium binding protein. So that calcium binding protein which increases the calcium absorption. Okay, simple, right? When you read from book, no, it will be like something hectic and somewhat you will have some fear. Oh my god, what they have given something like this. You try to make it as notes, then you will understand the point. Okay, the same way I understood this point. Okay, how it acts on kidney. In kidney, no, calcitriol promotes the reabsorption of calcium. Okay, see, the main function of calcitriol is it increases the blood calcium level. In intestine, it is being absorbed. In kidney, it is being reabsorbed by renal tubules of kidney and thus reducing excretion of calcium and phosphate. So, when excretion of calcium and phosphate is decreases, uh, what happens? Automatically, reabsorption of calcium increases. No, same way. That's it. Then bone mineralization. Calcitriol stimulates the osteoblast. Okay, osteoblast. So these osteoblasts secrete alkaline phosphatase. Due to this enzyme, local concentration of phosphate is increased. So this alkaline phosphatase increases the local concentration of phosphate. The ionic product of calcium and phosphorus increases, leading to mineralization. So vitamin D is required for proper mineralization of bone. Okay. So what are the functions? In intestine, increases the calcium absorption, and kidney, reabsorption of calcium, and thus decreasing the excretion of calcium, and bone mineralization, where proper mineralization of bone. Okay. Then regulation of calcitriol. Hormone level of calcitriol is maintained by feedback control. What is mean by feedback control? We might have studied in physiology, right? Homeostasis, feedback control, positive feedback control, negative feedback control, like the same thing. How it regulate? How regulation of calcitriol happens? The rate of production is induced by serum levels of calcium, phosphorus, PTH, and calcitriol itself. I told no calcium. If overproduction of calcium, I mean over reabsorption of calcium takes place, calcitriol itself it acts as a feedback, okay, mechanism to reduce the level of calcium in the blood. See, everything has some limit, right? So if it exceeds some level, no, it leads to toxicity. So that level shouldn't be reached. So because of that only, feedback control are being uh, it plays a major role. Okay, so I told you already, parathyroid hormone. What parathyroid? Parathyroid hormone also acts on calcium absorption as calcitriol. Calcitonin decreases the calcium absorption. Calcitriol increases the calcium absorption. Okay, the major site of control is on 1-alpha hydroxylase of kidney. What is 1-alpha hydroxylase? We have seen this somewhere, right? Yeah, see, in absorption, no, see, here when 25 cholecalciferol is being converted to 125 dihydroxy, here 1 hydroxylase is being acted. Okay, the major site of control is on 1-alpha hydroxylase of kidney. Hypercalcemia. What is hypercalcemia? We all know it is a basic thing. Hyperproduction of calcium decreases calcitriol. Okay, so low density calcium and hypocalcemia increases the rate production of calcitriol. See, the basic function of calcitriol is to increase the blood calcium level. In proper words, to maintain the blood calcium levels. Okay, so hypercalcemia, when overproduction of calcium occurs, it decreases the calcitriol. Because it is already calcitriol will increase the calcium levels. If it hypercalcemia, how calcitriol will act? It is a basic thing, right? Okay, then hypocalcemia. In this matter only, calcitriol plays an important role. Low density calcium and hypocalcemia increases the rate production of calcitriol. Okay, the half life of 125 DHC is 6 to 8 hours and is mainly excreted through bile. Okay, so calcitriol is mainly excreted through bile. 125 DHC is nothing but calcitriol. Its half life is 6 to 8 hours and is mainly excreted through bile. So absorption is very important, sites of action is very important, regulation of calcitriol is very important. So these three topics you shouldn't miss when you are writing a 15-mark question on vitamin D, and vitamin D is also an important 15-mark question which is being asked in university examination of first year of MBBS. Okay, then we will see about vitamin D deficiency. Yeah, okay. The presence of melanin will decrease the formation of vitamin D3 on skin. Okay, Melanin what? It is a pigmentation, melanin pigment. Okay. The deficiency is more common in obese people. Okay. Vitamin D deficiency is more common in obese people because vitamin D is stored in adipose tissue and not released for utilization. Where? In obese people. So in obese people, it is stored in adipose tissue and not released for utilization. Why adipose tissue? Yeah, because it's fat soluble, right? Fat soluble vitamin. It's a basic thing. It's a fat soluble vitamin, so it is more than is stored in adipose tissue. It is not released for absorption. Abnormality of vitamin D activation, liver and renal diseases may retard the hydroxylation reactions. Deficiency can lead to reduced bone density. So reduced bone density is nothing but that condition is known as osteoporosis. So osteoporosis means reduced bone density. So we saw, right, the sites of actions of vitamin D, one in intestine, one in kidney and in bone mineralization, right? So calcitriol plays an important role in bone mineralization. So the same way with deficiency leads to osteoporosis, which is nothing but low bone density, reduced bone density. Okay. Clinical features. What are the clinical features? Rickets. We all know rickets. We might have studied in 12th standard, right? Not from 12th standard. Some might have studied in 10th standard. Even this disease is seen in children. Insufficient mineralization of bones. Okay. Bones become soft and pliable. Okay. Plasma calcium and phosphorus are low normal. Hypocalcemia is seen. Below normal levels of hypocalcemia is seen because of deficiency of vitamin D. Okay, why low calcium? Because vitamin D calcitriol increases the calcium levels only. No, so we need deficiency will leads to plasma calcium and phosphorus becomes low only. Okay. Different types of rickets. So this rickets is it's important. This is it will be coming through the MBBS live with you. Okay, rickets. Different types of rickets is seen. Okay, hypophosphatemic rickets, vitamin D resistant rickets, renal rickets. Okay, hypophosphatemic rickets. See, the name itself explains you. Hypo means low, phosphatemic rickets means phosphatemic means it's something related to phosphorus, right? So rickets, it is a disease. So defective renal tubular reabsorption of phosphate. Simple. So renal tubular reabsorption of phosphate decreases. Defective means nothing decreases because of the rickets is happening. Nothing but hypophosphatemic rickets. Vitamin D resistant rickets is found to be associated with Fanconi syndrome, where the renal tubular reabsorption of bicarbonate, phosphate, glucose, amino acids are also deficient. So vitamin D resistant, there is no difference in hypophosphatemic. Hypophosphatemic is related only to phosphate. Vitamin D is related to amino acids, reabsorption of bicarbonate, glucose, amino acids as well. Renal rickets is even if vitamin D is available, calcitriol is not synthesized. Why? Why think? It's simple actually. In renal, no. 125 DHC, which is nothing but calcitriol, is formed from 25 DHC through 1 alpha hydroxylase, right? In kidney, it is an enzyme. I showed you, right? 1 alpha hydroxylase. Though that enzyme deficient will lead to the deficient synthesis of calcitriol. So in that case, if 1 alpha hydroxylase is not available, calcitriol is not formed, which leads to renal rickets. Okay. Then osteomalacia. The bones are softened due to insufficient mineralization and increased osteoporosis. So osteoporosis, I told you, right? Low bone density. So low bone density will be increased, the bones are softened and mineralization will not happen because of vitamin D deficiency. Okay, onycholysis may be seen in mice. So this onycholysis picture have been given in Vasudevan. So see, I have so you can refer Vasudevan also. See, keep these notes aside Vasudevan. Just read Vasudevan once. Okay, see the pictures. What clinical pictures they have given. See the ones. Okay, see those pictures once, and study these notes. You will be very clear, and you will not forget these points at all. Okay, I have written those Vasudevan points only as a single point. Okay, in Vasudevan they will be in paragraph, but I have written in a separate points. because when you write in points, you'll remember how many points you wrote for each topic. So in that way you can remember each and every topic. Okay, you will not leave the important ones. See here I have written low serum calcium and low serum phosphate in red color. Okay, so you will not forget. Oh, okay, you have to read this point. You will be concentrating on that point as well, so you will not forget. Okay, abnormalities are slightly low serum calcium and low serum phosphate. Tetany will not be manifested. Serum alkaline phosphate is increased because of it. Because of when serum alkaline phosphate is increased means what? Phosphate absorption is increased. Okay, then in pregnancy low levels of vitamin D in pregnancy are associated with gestational diabetes, preeclampsia and small size of infants. So when in pregnancy, what happens if vitamin D deficiency comes in pregnancy? These are the cases. Maternal vitamin D deficiency may cause impairment of bones quality after birth. So the child may have soft and pliable bones. The proper mineralization of bone will not be seen in child. Okay, where in maternal vitamin D deficiency. Okay, in serious disease, vitamin D deficient patients presents a high risk of cardiovascular disease, decreased DHC concentrations in blood, and risk of cardiovascular disease, stroke, cancer, fractures, and mortality. Why? 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 See, think. In calcium. So what happens? Vitamin D deficient. Vitamin D deficient means calcium will be blood calcium level will be lowered. Okay. So for muscle contraction in heart, cardio in myocardium muscle for muscle contraction, calcium also plays a major role. So because of that only high risk of cardiovascular disease are being observed. So calcium, potassium, so these are all important for muscle contraction, mainly for myocardium, which is a muscle, heart muscle. So if muscle contraction doesn't take place, how heart will be pumped? Okay, so calcium is important for that also. So blood calcium levels is one of the most important thing, and it is regulated by calcitriol, calcitonin, as well parathyroid hormone also. Okay. So we'll be studying a separate chapter in both biochemistry and physiology as well. Okay. Then okay, we have came to RDA, requirement of vitamin D, which is nothing but recommended daily allowance for infants, children, adult males and females, pregnancy and lactation. So you can remember in the order which I have given for vitamin A also, starting from adult males and females, pregnancy, lactation, infants and children. Okay, male, female. So then what happens? Pregnancy. After pregnancy, what happens? Lactation. After lactation, what happens? Infants. After infants, children. So you can remember in this order. So I have given these values. So IU nothing but international units. So you can also remember in international units, and you can also remember 10 microgram. So it is safe to remember both the values. Okay, because they might ask this question in MCQs as well. Okay, serum vitamin D3. So this is extra. Okay, reference level is 330 nanogram ml. Okay, 1 nanogram is nothing but 2.5 moles. Okay, like this value is important for at which level vitamin D toxicity happens. So because of that only we are learning this value. 20 to 29 nanogram milliliter, it is insufficient. Okay, insufficient vitamin D. Okay, if this value comes 20 to 29 nanogram milliliter, vitamin D is insufficient. So 11 to 20 is deficient. Okay, less than 20, it is severe deficiency of vitamin D. Okay, more than 150 nanogram per milliliter, it leads to toxicity. Okay, what? Vitamin D toxicity. Yeah, vitamin D toxicity also occurs, but it doesn't occurs through sunlight, because we have to remember this, because vitamin D is a sunshine vitamin. Everyone will be telling, as it is a sunshine vitamin, overexposure to sun leads to vitamin D toxicity. So it doesn't. Okay, it will not occur. You have to remember. Okay, as it is a basic point. But we will be forgetting, because as words explains, no, sunshine vitamin. Okay, if more sun, if we are exposed to more sun, it leads to toxicity, like that we will be saying. So that's not true. Okay, that's false. So remember, I'm again saying, even though it's a sunshine vitamin, overexposure to sunlight doesn't lead to vitamin D toxicity. Okay, methods to measure vitamin D in blood: ELISA, chemiluminescence immunoassay, high performance liquid chromatography, tandem mass spectroscopy. So you can remember any two or any three among these. Sources of vitamin D: exposure to sunlight first, then fish liver oil, egg yolk, fish, etc. Adequate exposure to sunlight without sunscreen before 10 a.m. and after 3 p.m. at least 15 minutes a day. Okay. Then hypervitaminosis of vitamin A. As we have seen hypervitaminosis of vitamin A, oh my god, I have written it wrong. So this is for vitamin D, right? Okay. So please change it. Shit. See what silly mistakes I am. Okay, hypervitaminosis of vitamin D, not A, guys. I'm again saying it is hypervitaminosis of vitamin D. Okay, levels above 150 nanogram per milliliter in serum are definitely toxic. Tolerable upper limit is fixed as 4000 international units per day for adults and 1000 international units per day for infants. What are the symptoms of vitamin D toxicity? Weakness, polyuria, intense thirst, difficulty in speaking, hypertension, and weight loss. Hypercalcemia leads to calcification of soft tissues. Excessive exposure to sunlight does not result in vitamin D toxicity because excess D3 is destroyed by sunlight itself. Okay, these points are so nice. Okay, I have written it's a small mistake here. Vitamin D. I'm noticing now only hypervitaminosis of vitamin D, and it is not vitamin A. Okay, please change it. I will also change and will upload the PDF in Telegram link. Okay, so you can change there. Okay, that's all for now. I have completed vitamin D and vitamin A. So these two are important 15 mark question which is being asked in second paper. Okay, so second paper or first paper, I don't remember actually. So both these are important 15 mark questions. You have to study thoroughly. Many questions can be asked in vitamin A and vitamin D. Of course, all those vitamins are important, but these two is the basic vitamins we have to remember. Okay, that's why I have made a separate video for vitamin A and vitamin D. So next video will be covering up vitamin E and vitamin K. So you can write these notes for 15 mark questions, will be very useful for you. So as I have already told, study Vasudevan and keep these notes aside and just refer to these notes and see the pictures there and twinkle pictures there. Nothing but I have written the notes, I mean the paragraph which I have written in Vasudevan, I have written as points, okay, separate points. Nothing much different seen in this video. So that's all for now. Thank you. Subscribe this channel. Subscribe to Medjo. Okay. See you next video.